These are our notes on proofs. When stating proofs, we always want to remember that we are going to always state the given first. I put usually here, but in most cases we're going to state the given first. Then we're going to finish with what it says to prove. And we also want to remember that all the reasons that we'll list down here are theorems that we have used before. So in example 1, this is the figure we're given, and we can see all of the givens listed over here, as well as what it wants us to prove. So, one of the first givens, our first statement, is segment AB is congruent to segment CD. So I'm going to come up here first and mark those. So segment AB is congruent to segment CD. And since that was given to us, for this statement, segment AB is congruent to segment CD, I'm just going to write for my reason that that was a given. For our second statement here, it states that segment BC is congruent to segment DA. So again, segment BC is congruent to segment DA, which we have marked there. And for our reason, again, we are going to state given because those were both given to us over here. For the third statement, it states that segment DB is congruent to segment DB, which we can see right here is segment DB, and it's saying that it's congruent to itself. So I'm going to mark that on here. Segment DB is congruent to segment DB. So we can see we have two triangles, and this segment is congruent on both triangles. And we call that the reflexive property. And that's the property that is used when a figure is congruent to itself. So down here, we're just going to write reflexive property. And remember, we use that anytime that a figure is congruent to itself. And for the fourth statement, it wants us to prove, and it says that triangle ABD, so triangle ABD, is congruent to triangle CDB. And for that, we're going to state the theorem for our reason that we have side, side, side. So it's going to be the side, side, side theorem. So for that, we'll just write side, side, side theorem. And this is how we state our proofs. In this next example, we can see that we're given that B is the midpoint of segment CE and AD. So B is the midpoint. And we need to prove that triangle ABE is congruent to triangle DBC. So in our statements, we can see that B is the midpoint of segment CE and segment AD. So for our reason here for this one, we can just state that that was given because they told us that up here. In the second statement, it states that EB is congruent to CB. So here we can mark that segment EB is congruent to segment CB. And again, for that, we can put definition of a midpoint, because we knew and we were given that B was our midpoint of those two segments. For the next one, we have segment AB is congruent to segment DB. So again, we can mark those. We can say segment AB is congruent to segment DB. And again, for that, we can write definition of a midpoint. Because again, we know that B is our midpoint there. For our next statement, it states that angle ABE, so angle ABE, is congruent to angle DBC. So we're just going to draw those in here. Angle ABE is congruent to angle DBC. And for that, we can write that vertical angles are congruent. And because those would be vertical angles. And for our last statement, triangle ABE is congruent to triangle DBC. For that, looking up here, we can see that we have the theorem side angle side, side angle side. So down here, we can write for our reason side angle side. In example 3 here, we are given that angle V is congruent to angle M, and segment LJ is congruent to segment YJ. And we need to prove that triangle LJV is congruent to triangle YJM. In our statements here, our first statement is that angle V is congruent to angle M. So up here, we're just going to mark that. Angle V is congruent to angle M. And for our reasons for this one, we're just going to state that that was given, and it was given to us up here. Our next statement is that segment LJ is congruent to segment YJ. So we can mark those here. Segment LJ is congruent to segment YJ. And again, over on this side, we can just simply write for that one that that was a given as well. And for our next statement, we have that angle YJM is congruent to angle LJV. So angle YJM is congruent to angle LJV. And for that one, we can simply write that vertical angles are congruent. And then our last statement is that triangle LJV, so triangle LJV is congruent to triangle YJM. And for that, we can state, just like we can see here, that we have the theorem angle, angle, side. So for this one, we would state angle, angle, side theorem as our reason. In our last example, we are given that segment AC bisects angle BAD, and that segment AC is a perpendicular bisector to segment DB, and we need to prove that triangle ADC is congruent to triangle ABC. So our first statement is that segment AC bisects angle BAD. So here we have segment AC, and it's telling us that that is bisecting angle BAD. So we could even draw that in here. And then it says so for this statement, we should write for this one that that was given, because it told us that right up here, that AC bisects angle BAD. In our second statement, it tells us that segment AC is a perpendicular bisector to DB. So here again we have segment AC, and we can see that that is a perpendicular bisector to DB. So down here we can state again that that is a given. And since it's a bisector, we also can draw in here that it's bisecting. For statement 3, it tells us that angle DAC, so angle DAC right here, is congruent to angle BAC. So we have those drawn in there, and we know that they're congruent because this was a bisector. So for that, for our reason, we are going to just simply write definition of a bisector. For our next statement, angle ACD and angle ACB are right angles. Okay, and we can see that here because we had a perpendicular bisector. So for this, we are simply going to write for our reason definition of a perpendicular bisector. And for our next statement, angle ACD is congruent to angle ACB. So again, angle ACD is congruent to angle ACB. So if we look up here, we've got ACD, and we can see here that we've got a right angle is congruent to angle ACB. And again, we've got another right angle on this side. So for this statement, for our reason, we would say that right angles are congruent. And for our next statement, it states that segment DC is congruent to segment BC. So looking up here, we can see segment DC is congruent to segment BC. So we write those on there. And for this one, we can write that our reason is definition of a perpendicular bisector. And for our last statement, it states that triangle ADC is congruent to triangle ABC. So triangle ADC is congruent to triangle ABC. And for this statement, we would want to write our reason as theorem angle, angle, side. So down here we would just write angle, angle, side theorem.